So in this video I want to talk about factorials and cancelling, and I want to just revisit factorial notation, remind you of what it is. I'm going to define what 0 factorial is, and then we're going to look at cancelling through division. 1 factorial is just defined as being 1. 2 factorial, to take 2 factorial we take 2 and we multiply it by 1 factorial. 3 factorial is 3 by 2 factorial. 4 factorial is 4 by 3 factorial. 5 factorial is 5 by 4 factorial. And that's what factorials are. Notice 2 by 1 factorial, well, that's just 2 times 1. So 3 by 2 factorial is just 3 by 2 by 1. 4 by 3 factorial then is 4 by, well, 3 factorial is 3 by 2 by 1. 5 by 4 factorial is 5 by 4 factorial is 4 by 3 by 2 by 1. Each of these things can be calculated. Reasonably straightforward. 2 by 1 is 2, 3 by 2 by 1 is 6, 4 times 6 is 24, 5 times that is 120, 6 factorial I can work out would be 720, etc., etc. So to take a factorial, what we do is we take the number and we multiply it by all natural numbers less than it. The other thing is we're only taking factorials of natural numbers. We're only dealing with natural numbers here. And so we take a factorial of a natural number, we take that natural number and we multiply it by all natural numbers that are less than it. So take the factorial of 5, we multiply it by all the natural numbers that are less than it. So 5 by 4 by 3 by 2 by 1. Okay, there is a definition for 0 factorial because it doesn't really fit in with my system. 0 is not a natural number and there's no natural numbers less than it or equal to it. So what we do is we just define 0 factorial to be equal to 1. Okay? Outside of that you can't find factorials of any other numbers. Okay? They're not defined for anything else. So you type into your calculator 1.5 factorial, your calculator won't be able to read it until you've made a math error. So that's factorials. I want to look now at cancelling factorials through division. Cancelling factorials through division. And the kind of number crunching is going to be quite simple here. But what I'm really interested in is establishing patterns. As we always are in mathematics, we're always on the lookout for patterns. Okay, and here's 2 important questions. After cancelling, how many numbers are multiplying? And I want to identify then the biggest and smallest numbers and see if I can find, a pattern emerging. So let's look at this one. You probably know the answer to this already. I'm going to write this out. That's 5 by 4 by 3 by 2 by 1 factorial on the top, and on the bottom it's just 1 factorial. And what I really want you to see is that 1 factorial is a factor on the top and a factor on the bottom, so they will cancel, leaving me with 5 by 4 by 3 by 2. How many numbers are multiplying? The 4 numbers here. Identify the biggest and smallest. Well, the biggest is 5. And the smallest is 2. So there's 4 numbers multiplying. 5 by 4 by 3 by 2. 4 multipliers. Biggest 5, smallest 2. Okay? And we'll come back to that again. I'm going to look at the second one. 5 factorial divided by 2 factorial. Well, that's 5 by 4 by 3 by 2 factorial. All divided by 2 factorial. And what you're getting here is cancelling. And you probably see already you'll always get this kind of cancelling happen. And what we're getting is 5 by 4 by 3. How many numbers are multiplying after cancelling? Well, there's only 3 numbers in here. And the biggest number in that list is 5, and the smallest is 3. So 3 multipliers, biggest number is 5, smallest is 3. 5 factorial divided by 3 factorial, well that's 5 by 4 by 3 factorial, all divided by 3 factorial, and there's going to be cancellation there. Okay, and that's just 5 by 4, which of course is 20, but really I'm interested in establishing some patterns here. How many numbers are multiplying here? Well, there are 2 numbers multiplying, 5 by 4, so 2 numbers multiplying in here. The biggest number is 5, and the smallest is 4. And we're going to look at 5 factorial divided by 4 factorial. Well, 5 factorial is 5 by 4 factorial over 4 factorial. And again, what you'll see is there's only one term in there. One number multiplying, 5. And then we have the biggest is 5 and the smallest is 4. Sorry, biggest is 5, but the smallest is 5. It's just 5. Okay, 5 factorial divided by 5 factorial, well that just cancels out, leaving me with 1. Okay, it just leaves me with 1. So after cancelling how many numbers are multiplying, identify the biggest and the smallest. So if we're thinking about our patterns, first of all, in this, when I divided 5 factorial by 1 factorial, there were 4 terms remaining after cancellation. 5 factorial divided by 2 factorial had 3 terms remaining after cancellation. 5 factorial divided by 3 factorial had 2 terms remaining after cancellation. 5 factorial divided by 4 factorial had 1 term remaining after cancellation. So what is the pattern? Well, this is the pattern. If I subtract the number on the bottom, 1, from the number on the top, 5, I get 4. If I subtract 2 from 5, I get 3. If I subtract 3 from 5, I get 2. If I subtract 4 from 5, I get 1. So that's how we figure out how many terms. So 7 factorial divided by 5 factorial, after cancelling there will be 2 terms. 20 factorial divided by 18 factorial, after cancelling there will be 2 terms. 10 factorial divided by 4 factorial, after cancelling there will be 6 terms. 100 factorial divided by 15 factorial, after cancelling there will be 85 terms, 100 minus 15. Let's look at the biggest number. The biggest number in every case is 5. Where does that come from? Well, that's just the number up here on the top. And the smallest number, well, in the first case it's 2, in the second case it's 3, and the number on the bottom is 2. The smallest number here is 3, and the number on the bottom is 3. The smallest number here is 4, and the number on the bottom is 4. The smallest number here is 5. Okay? So the smallest number is always 1 bigger than whatever the number on the bottom here is. So 1 bigger than 1, that's 2. 1 bigger than 2 is 3. 1 bigger than 3 is 4. 1 bigger than 4 is 5. Okay? Note 5 factorial divided by 5 factorial is just 1. So kind of just is a very simple thing. But I'm looking for these other things. So if I look at 7 factorial divided by 5 factorial, I know straight away there's going to be 2 numbers multiplying. The biggest will be 7, and the smallest will be 1 bigger than 5, which will be 6. 20 factorial divided by 18 factorial. I know that 20 minus 18 is 2. There's going to be 2 numbers multiplying. The biggest will be 20, and the smallest will be 1 bigger than 18, which is 19. Okay, let me just open a bit of space for these last 2. I need a little bit of space here. So if I look at 10 factorial divided by 4 factorial, how many terms will there be? How many numbers multiplying? Well, there will be 6 numbers multiplying. 10 minus 4 is 6. The biggest will be the number on top, 10. And the smallest will be 1 bigger than that number on the bottom, which is 5. So 10 by 9 by 8 by 7 by 6 by 5. And again, notice that's 6 numbers all multiplying. 100 factorial divided by 15 factorial. How many numbers are going to be multiplying all together? Well, there's going to be 85. 100 subtract 15, 85. Now I'm not going to write out all 85 numbers, but it will be 100 by 99, by 98, by 97, by 96. Just put in a little ellipsis there to say and so on, until we get to the smallest number, which will be 1 bigger than 15, which will be 60. So that is how we cancel when we're dividing factorials. Okay? That's how we cancel when we're dividing factorials. Okay, so in general, if I want to divide n factorial by r factorial, well, my first term, my biggest term, will be n. And then my second term will be 1 less than that, n minus 1. And then my third term will be 1 less than that, n minus 2. And that'll go all the way down until my last term, which will be 1 bigger than r. How many terms will there be altogether? How many numbers altogether multiplying? Well, there'll be n minus r multipliers in that list. Okay, so well worth remembering that. Learn the pattern, help you. You'll be dealing with factorials quite a bit, so it helps you work out things a little bit quicker.